Hello, am I audible? Hello.
Yes, sir.
Okay.
Yes, sir.
So this is an important topic. Okay, which is called as histogram processing. So we'll be having one problem from this. It will be carrying around 12 marks. So be attentive while listening to the uh, concept of this histogram processing. So when you come for histogram, so we are having these many topics. So the first one would be histogram equalization, the next is histogram matching, local histogram processing, and using histogram statistics for image enhancement. Okay, under histogram it will be coming under these four topics. If we consider histogram, the first thing is you need to know what is meant by histogram. So this is nothing but a graph representation of the data. So it is similar to your bar graph. So it is almost similar to a bar graph. The only difference is here we will be applying the a graph to a particular range. Okay, so the height of each bar shows how many fall into each range. So this is an important uh, point where you need to concentrate. So here will be classifying the data which falls under certain range. So if you are using bar graph, what you do was let us consider this as a bar graph. If it was a bar graph, what you tend to do was you would take two axes. One would be your x-axis and other would be your y-axis. And here we will be writing it as 0. Let us consider 1, 2, 3, and 4. And in the bar graph, we'll be taking only one particular value, and you'll be, let us consider if your image is having values. There is a 3 cross 3, it is a 3 cross 3 image. So in this the amount of data has to be plotted using bar graph. Means let us consider the value present here is 1 1 1, and this is 2 2 1 1 1 and 1. So the amount of 1 which is contained here is 1 2 3 4 5 6 7. So say there are 7 ones. So we'll be taking along the y-axis as 2 4 6 8. So 1 is present how many times? 7 times. So we'll be marking this as 7. Okay, we'll be marking this as 7, and the amount of 2 present is will be 2 2s. So we'll be taking this as 2. Okay, so this is how we'll be plotting which graph? Bar graph. Whereas in histogram, what we'll be doing is it'll be classifying the data depending upon the range. So if you look over here, so we'll be taking the data from 40 to 60. Okay, in the x-axis the range is 0, 40, 60, 80, 100, 120 and 140. So whatever the data which comes be between these two, if it is 55 means it falls under this range. If it is 58 means again it will be plotted in between these two ranges. Okay, if it is 81 means it will be plotted here. Okay, so there is a continuity in the graph. So it's almost equivalent to what? Continuous graph. So here the height of each bar will be showing which data will fall into which range. Okay, in which range the data will be falling, that will be shown. That is the only difference between what? Your bar graph and your histogram graph. The rest of the thing is same. In case of bar graph, there will be only particular value given, whereas here there will be range from one particular range to one particular range. Clear with that? Hello?
Yes, sir.
Okay.
Yes, sir.
So the main thing is between range. There will be range and you will be entering the data in that range, whereas in case of bar graph there is only one particular value. So the same thing which I explained earlier is being shown over here. So if you consider, histograms are a great way to show results of continuous data. Okay, it is a great way to show continuous data such as weight, height, how much time, etc. Okay, whereas but when the data is in categorized form such as country or a very favorite maybe, then you'll be using bar chart. So you can look the difference between bar graph and histogram. So the histogram is what? Continuous. It is being categorized. If you take the some y-axis value, let us consider this is the uh, uh, profit which is obtained in particular country. In USA it is around 150, in India it is 300. So there is a gap between these two bars. Okay, so this economy is considered only for India, whereas this is only for UK, whereas here is not the type. Okay, here will be just indicating the range, so from 100 to 150. So if the value is 120 means it falls under this range. Next, there is no gap between this 150 and the next number. It continues right from here, 150 to 200, the next. Okay, so this is continuous in nature, whereas in case of bar graph there will be discrete in nature. So this is the major thing which you need to know regarding the histogram. Now what we will be doing is, it will be okay, clear with this concept, bar graph and histogram. Hello.
Yes, sir.
Okay, now let us look how would you use this. Let's look at the use of histogram. Okay, so usually the histogram will be used to increase the contrast of an image or brightness of an image, or it can be used to compress the image. So these are the different things which you can do with histogram. So are you able to see this image? Hello.
Yes, sir.
Okay, so this is the image. Okay, this is the image, and the histograph of this image is being given over here. Okay, this is the image and the histogram of the image is given over here. So if we consider here, this is the intensity range. Okay, this in your textbook intensity, since it's an, you just look over here, what is it, it's an 8-bit image. Okay, if it's an 8-bit image means it can have values from where, it can have values from 0 to how much, 8-bit means 0 to, hello, ಎಷ್ಟಿರುತ್ತೆ,
7, sir.
7.
0 to 8, 2 to the power of how many levels, 2 to the power of 8-bit image, 2 to the power of 0 to 2 to the power of 8, so it would be 0 to 2, ಎಷ್ಟು ಬರುತ್ತೆ,
256.
255. So this is the
256.
intensity
450.
image. Okay, so here you take an intensity R. Okay, it ranges from where 0 to 255. So this is your 255. So this is your number. We're calling this as probability of R. Okay, so what we'll be doing is this particular first line, it indicates that there are 1898. Okay, intensity is here somewhere, the intensity is how much? 98. Okay, 98 intensity containing elements will be around 1800. Okay, so what does it indicate is, so this is your image, right? So I is the image, which is consisting of how much? 291 cross or 240. Okay, 290 into 240, so that gives you how much? 69,600 elements are there. Okay, 69,600 elements are there. Each element, okay, or each pixel will be having some particular intensity. So if you look here, so there are how much? 69,600 elements are present in this image. Each element, okay, will be having some particular value, but the maximum value is how much? Eshrita, maximum value can be how much? It can be the maximum value can be how much?
250.
255, and the minimum value is how much? 0. So 107, 108, 107. So it will be this. Okay. Now what we need to do is we need to plot the histogram of this image. So when you consider histogram of this image, nothing but you just need to calculate how many elements of particular range are present. They are given 0 to 255 over here. So here you are telling that an element with 98, okay, will be containing 1800 elements, or density value is how much? 98. Similarly, if you consider here, so there are around 6000 elements whose intensity value is of 100. Similarly, we will be plotting all the intensity values. Clear with this? Hello? Hello?
Yes, sir.
Okay. So that is what histogram does for you. Okay. So it takes intensity along the x-axis. It will be called as R, and you will be plotting the number of that particular intensity on the particular intensity along the y-axis. So that is called as histogram of the image. Okay. So now you would be having a question: what do you do with advantages with the histogram? So if you, this is the histogram, right? If you carefully look over here, it is, hello, the histogram is concentrated where? It is present at what? The center. If you try to stretch this, okay, if you try to stretch this, the image becomes brighter. Clear with that?
Yes, sir.
Okay, if you try to stretch this histogram, the image, look how this image looks when this histogram is being stretched. Okay, so for that, so if you look at this image, what we have done is we have stretched the histogram. If the histogram is being stretched, what has happened to the image? The brightness of the image is being increased, isn't it? Hello?
Yes, sir.
Okay, so this is what we need to do with the histogram. Okay, clear with this concept?
Yes, sir.
So the problem what you'll be solving right now is you'll be taking the histogram of the image and you'll be spreading that histogram. Okay, the spreading of histogram is itself called as histogram equalization. Okay, so now let us consider the problem. uh, Keep the notebook along with you. Okay, uh, just write on this question. So this is very important from exam point of view. Okay, write on the first question. Suppose that a 3 bit suppose that a 3-bit image of size 64 cross 64 64 cross 64 pixels has the intensity distribution as shown below. Then find the histogram of the image. Then find the histogram of the image. Have you taken it down? Hello?
Sir.
Okay, it's an a 3-bit image. Okay, so if it's 3-bit means the number of levels would be 2 to the power of 3. Okay, it's nothing but 2 to the power of k. So how many levels would be there? There will be 8 levels. Clear with that?
Yes, sir.
Okay, then they are given what? 64 cross 64, that is number of rows is 64 and number of columns is how much? 64. So 64 into 64 into 64. So what is the value? How much do you get? 64 into 64?
4096.
4096. Okay, so there are how many pixels? There are 4006 pixels present. Okay, so the level is how much? There are only 8 levels, 0 to 7, since it's a 3-bit image. So in the MATLAB what you saw, there were so it was power of 8, so 0 to 255. Since it's 3 bit, so 2 to the power of 3 it is 8, so it would be 0 to 7. Okay, so first uh, write on 3 nk and probability of rk, probability of rk. So there will be 3 columns: rk, have made 3 columns. Hello. Hello.
Yes, sir.
Okay, so intensity levels are how much? 8. So it will be from, so it is 0, 1, 2, 3, 4, 5, 6 and 7. So totally there are, this is your original image. So there are 8 intensity, 0 to 7. Let us name this as R0. Okay, let us name this as, R0 equals 0, R1, R1 equals, next this is R2, next this is your R3, next this would, next this would be a R5, and this is R6, and this is your R7. R7 equals 7. Clear here? Hello. Hello.
Yes, sir.
Okay, next they have given cells 4096. Okay, so each intensity cells would be of particular number. So here the pixel with intensity 0 is 790. Okay, so there are 790 pixels with intensity how much? 0. Similarly 1023 pixels with intensity, there is 850 pixels with intensity 2. Similarly there are 656. Next there are 329, 4. Next there are 245 pixels with intensity 5. Next 122 pixels with intensity 6 and 81 pixels with intensity. Have you noted down?
Yes, sir.
Okay, so when you add up all these elements, okay, when you add up all these elements, this should be equal to how much? Estirbeko. When you add up all these elements, it should be equal to
4096.
4096. Okay, it should be equal to 40, 4096. So in the exam they'll R no, RK and NK. Next you need to calculate the probability of RK. Okay, so this is nothing but it will be normalizing the value. So normalizing is called as, here you can write the formula as probability of RK, which NK divided by Mn, NK divided by Mn. Okay, okay, you can write this as M cross N. So you need to, how much? M cross N, that is 4096. So what's the value here? 790. So it is how much? 790 divided by 4096. So what is the value?
0.192.
0.19. Okay, to just take two decimal values, that's sufficient. 0.19. Okay, next 1023 divided by 4096, what is the value?
0.24.
Point
0.24.
point two. What's the next digit?
9.
9 means you need to round it off. Okay, so you'll be writing it as 0.25. So if the round it off to the next value, if it is less than 5 means we round it. It was 0.243, you would have written it as 0.24. Since it is 0.25249, we will write round next number.
0.21.
0.21. Next
0.16.
0.16. So 0.16. Next
0.08.
0.08. Next
0.06.
0.06. Next would be 0.03.
03.
0.02.
0.02.
Okay, so now we have got the probability of the samples and the samples. So already you know that histogram is the, so along the x axis will be having r. Okay, so this is nothing but what? This as r k. So it will be starting from 0. So how many levels are there? 8 levels. 0 to 0, 1, 2, 3, 4, 5. So these are the levels rk. Next along the y, so this is nothing but you need to take probability of rk. Okay, probability of rk. So you need to plot this and 0.05. Next is 0.05. Next 0.10. Next 0.15. Next 0.20. Next 0.2. 0.25. Clear with that? Hello. So we'll be calling this as original histogram. We'll be calling this as original histogram. So now have you done it here? Hello. Hello.
Yes, sir.
Okay. Now 0. If you consider 0, So what is probability? It is 0.19. You can mark this is 0.19. Next one is how much? 0. Is how much? 0.25. Next 2 is 0.21, so it is 0.21. Next 3 is 0.16, so 3 is 0.16. 4 is so 0.08. Next 5 is 0.06. Next 6 is 0.03. 6 is 0.03, and 7 is 0. So you can so now you can draw the so this is 1, and this is for 3, and this is for 4, 5. So this is for 6, and this is for 7. Okay, this is how you will be getting the histogram of the image. Hello.
Yes,
Hello.
sir.
Okay, this image, so this is your original image. Still now you are not into the solution of the problem, a given statement. Okay, so this is the thing which is to equalize the image. So that's called as histogram equalization transformation function. Okay, so now what will be as you know that it's a basic transformation function. So the output would be what? S is your output. So how do you get S? By applying some input values, which is R. So this is what your basic intensity transfer has. Now there are 7 values. Okay, there are 7 values. Those intensity values has to be transferred. So what you'll be doing is, instead of S, you so you can take that as sk. You can write this as sk equals transformation on r of k. So since you are making use of basic intensity transformation on each individual intensity level, and you'll be getting the output which is sk. So first r naught, you'll be getting s naught, r1 means s1, r2 means r7 means s7. Clear with that? Hello.
Yes, sir.
Okay, now we formula sk. So the formula for sk is, so sk equals l minus, so l minus 1 summation j equals 0 to k p r of r j. So this is the formula. this formula, Sk equals L minus 1, J equals 0 to K. Hello? Hello?
Yes, sir.
Okay. Next, let us first try to find S naught. Okay. Let us first substitute K equals 0 over here. Okay. So we will be getting S0 equals a transformation which is applied on R of 0. So you already know the formula for Sk. Sk, that is K minus 1 into summation J equals 0 to J equals 0 to, what is the value of K? K is 0. Since here substitute K equals 0. R of Rj. So the value of L
8.
8. Okay, the value of L is 8. How did you got that? Since it's an 3-bit, so you can substitute how much? S naught equals 8 minus 1 is how much? 7. So you can write this as 7. If you remove the summation that is, if you expand the summation symbol, it is nothing but 1 into PR of R0. So there is only one element, 7 into PR of R0. So what is the value? So it is nothing but 7 into, what is it? PR of R0,
0.1.
0.19. Okay, so 7 into 0.19.
0.19.
Okay, so it is 7 into 0.
150.1.
7 into 0.19.
1.33.
0.3.
1.33. It is
33.
1.33. So this is your S naught equals 1.33. S naught equals 1.3. So S1. Next, let us calculate for what? S1. So have the formula Sk equals L minus 1 into summation equals 0 to K of PR of Rj. So this was the, now what we need to do, we need to find for K equals 1. Okay, next we'll be calculating for S1 equals 8. So 8 minus 1 is 7. So 7 into how much? Summation J equals 0 to 1 PR of Rj. So that is nothing but 7 into 7 into PR of R0 plus PR of R1. So that is nothing but 7 of R0 is nothing but how much? 0.19 plus PR of R1 0.25. What is the answer? 3.08. 3.08. Similarly, you need to find which one? S2. Okay. S2 equals into, so what is J is equal to 0 to 2, right? So what will be considered? PR of R0 plus PR of R1 plus PR of, so that would be 0.19 plus 0.25 plus 0.21. So what is the value? 4.55. So it is 4.55. Similarly, you need to find out for
There was a 4.48, sir.
4.
4.48, sir.
4.548. 6.4 round it up to 4.5. Or you one and you can just check it out once. It is coming around 4.55 itself. 7 into 0.19 plus 0.2 plus 0.
4.55,
Okay,
sir.
4.55 itself. Okay, so 4.55. Next is, so it is 7 into same thing up to PR of R naught up to, so what is the answer?
5.67.
5.67. So it is 5.67. Next, what is the value for S4? So 7 into
6.23.
6.23. So I'll be just writing 0.23. Next S5
6.65.
6.65 to 6.6. 6.65. Next
6.86.
86.
6.86. Next S7. S7 7.00. Okay.
7.
So S0 was 0. This is the okay, S0, S1, S2, S3, S4, S5, S6 and S7. Okay, how did you get these values? By applying some transformation. So this is called as a transformation function. Okay, now we'll be plotting the waveform, that is consider trying. Now we'll be plotting the histogram. So take this as RK. Okay, we'll be writing this as RK. So next, what so what is this? So this is nothing but SK. 0, 1, 2, 3, 4, 5, 6 and 7. So these are the RK values. Now along the SK axis, it 4, 2.8, next 4.2, 5.6, next 7.0. Have you taken it down? Hello? Hello? Hello?
Yes, sir.
Okay. So no need to attend the next class. You'll be engaging the class. Okay. Okay. No need to attend the next Hello.
Sir, cryptography ಇತ್ತು sir.
ಕ್ರಿಪ್ಟೋಗ್ರಫಿ
Cryptography, sir.
ಸರಿ, ಓಕೆ. ಜೆ ಸಿ
Cryptography,
ಸರಿಗೆ
sir.
ಹೇಳಿದ್ದೀನಿ ನಾನು, ಇಲ್ಲೇ ಇರಿ, ಬಿಟ್ಟೋಗ್ಬೇಡಿ, ಜಾಯ್ನ್ ಆಗಿ ಇಲ್ಲೇ ಇರಿ, ಅವ್ರಿಗೆ ಹೇಳಿದ್ದೀನಿ. ಸೊ this is your RK, so you obtained what? SK. Okay, now plot graph for this 0. Okay, 0 was S, this 0 1.33. Okay, 0 means it is converted to what? 1.33. What is the value for 1? It is how much? 1 means how much? S1 is S1
3.0.
3.8. Okay, so R1 was converted to 3.8. Okay, it is converted to 3. Next 2 means 2 on the extra 4.55. Okay.
2.5.
Hello madam. ಮೇಡಮ್
5.67.
ಕ್ಲಾಸಲ್ಲಿ ಇದ್ದೀನಿ, ಕ್ಲಾಸ್ ಇಲ್ಲ. So 3 is how much? 3 means 3 andre what is 3?
5.67. 5.6.
6 7. Next 4 means 6.23. 5 means 6. So here let me draw it here. So this here is S1, it's not S1. This here S2, this would be S3, S4. Next 6.65. Somewhere around 6.65. Next 6 point, next it is 7. Okay, so these are the so if we note this, okay, if we note this, hello, am I audible? Hello.
Yes, sir.
Okay, so if we note the output values S naught, so it is having fractional value 1.33, 3.08, 4.55. So all these are what? Signal processing. It has to be what? Integer. It has to be what? Integer. So what we need to do is we convert this fractional by rounding off to the nearest point values. Clear with that? So it is fractional. The answer which you have got is fractional. The making use of probability. Okay, since you are making use of probability, you are getting a fractional result. But digital image processing, in terms of what you will be doing is you will be rounding off the fractional part to the nearest value. If the 5 means you will be rounding off the number to the next number. If it is less than 5 means you will be rounding off to the least number. Okay, clear with that? Hello?
Yes, sir.
Hello? So you need to round off the values. Okay, S naught is 1.33. So you can write this as how much? 1.33 means you'll be writing this as how much?
1.3.
It will be written as only 1.
1.3.
Okay, 0.3, right? 1 point. You just consider the number after point. If it is greater than 5 means you round off this to the next number. If it is less than 3 means round it off to the least number. Okay, 1. Next, S1 is, what is the value of S1? Point. So 3.08. So this number is what? A 0. So you can round off this to how much? Value?
3.
3. Okay, so the value is what? 3. Next, S2. The value of S2 is what? 4. 4.55. So you can round it off to which number? Even if it is equal to 5, you just round it off to the next number. Okay, S not S1. What is S3? 5.67. So you can round this off to which number? Which number? It is rounded off to 6. Okay, next S4. S4 is 6.23. 6.23. It is rounded off to how much? How much? 6. S S5 is 6.65. It has to be rounded to which number? 7. And next S6 is 6.86. So it is rounded off to 7. Next S7 is 7. So it is rounded off. I will written it down. Hello?
Yes, sir.
Okay. Observe carefully over here. Okay, if you observe over here, so there is 1 but there is no 0. Okay, 0 is missing, 2 is missing, 4 is missing. So you lost these values, right? At the input was what was present? 0, 1, 2, 3, 4, 5, 6 and 7. Okay? So these were values. Okay, when you equalize the image, so what is missing here? 1 is missing, so 0 is missing. So these are the equalized values of histogram. Clear with that? Hello? 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 Hi,
Yes, sir.
Yes, sir.
Sorry, class ಇದೆ ಕಣೋ, 5 ನಿಮಿಷ ಕ್ಲಾಸ್. Hello, clear with this? Hello?
Yes, sir.
Yes,
Okay.
sir.
Okay, now will be
Yes, sir.
how many values, how many number of pixels are there with this. Okay, 1 3 5 6 6 7 7 and 7. Okay, now let us consider there are only 5 distinct values. Just write down next. There are only 5 distinct values, of intensities. So there are only 5 distinct values: 1 3 5 6 and 7. So if you consider there are only 5 distinct values, you look over here. So this is one distinct, 2, 3 and 5. So there are only 5 distinct values. Okay, now earlier the input was what? R naught was 0, R naught was equal 0, was mapped was R is mapped to S1, which is equal to 1. Okay, consider here. So 0, okay, 0 was mapped to which one? Okay, 0 is mapped to which one? 1. So writing this as R naught is mapped to how much? 1. Clear with that? Hello? Hello?
Yes, sir.
Okay, 0 is mapped to, so you are written as R naught equals 0 was mapped to S1, which is equal to 1. So how many pixels were there? You just, so you just go for R0. Okay, you need to calculate for which one? 0. But how many pixels were there with respect to 0? If we consider 0 means how many pixels were there? Pixels were there, right? Are you able to follow this? Hello? So here is what has happened here is
Yes, sir.
0 is mapped to 1, but 0 was containing how many pixels? 0 was containing 3 pixels. Okay, so you need to write here as, so there are how many pixels? There are 790 pixels. Okay, in the histogram equivalent Okay, so intensity of one will be containing how many pixels? 790 pixels. So R1, next value is what? R1 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 is mapped to which one? R1 is mapped to which value? Hello? Hello? R1 is mapped to which value?
Hello.
Is mapped to 3. So here we'll be writing this as R1 was mapped to S3, which is equal to 3. How many pixels would be there? Hello?
1023, sir.
Pixels. Okay, so it will be having 1023 pixels. Okay, present here. Next, R2 equals, so observe here, R2 equals 2 is mapped to which one? Is mapped to which one? Hello?
It's 5.
5.
5. So I'll be writing here as was mapped to, yes, 5, which is equal to 5. So how many pixels were there?
850.
There were 850 pixels. Next, you observe here R3 and R4. Okay, R3 and value, R3 and R4 is mapped to which value?
6.
6. Okay, they both are matched to a common intensity value 6. Okay, so we'll be writing this as R3, which is equal to 3, and R4, so they both will be mapped to as 6, which is equal to 6. So what is the pixels? What is the pixel? How many pixels? How many pixels would be there?
985.
985. Okay, it is the 6 plus 329. So it's combination of which? R3 plus R4. Okay, R3 is containing 656 pixel, R4 containing 329. So both of them are mapped to 6. Okay, which is equal to 985 pixels. if we consider, so your R5, R6, R7, all of them are mapped to which pixel? It is mapped to a 7. So your R5, R5, R6, R7, 5, 6, 7. So all of them would be mapped to S7, which is equal. So how many pixels would be there? How many pixels will be there?
448.
245.
448.
245 plus 122 plus 81. So that would be equal to 400, 448 pixels. Clear with this? So R0 is mapped to S1, R1 is mapped to S3, R2 is mapped to S5, R3 and R4 is mapped to S6, R5, R6, R7 is mapped to S7. Clear with this? Hello?
Yes, sir.
Yes,
Okay.
sir.
Now we need to draw the output histogram, which is the equalized histogram. Okay. So if now what we need to do is take x-axis and take y-axis. So here output is what? S. Okay. The domain is what? Sk. Okay. Clear with that? Output means what? Sk. Okay. So here it should be what? Whenever it's an histogram, it's nothing but what? If this is Sk, so this should be what? A probability of Sk. This should be probability of Sk.
RK.
So this, if this was Rk, means at the output you will be getting what? S domain, right? Since it is Sk, means it should be what? Probability of Sk. So you look over here. We're trying to write the histogram, right? Histograms means always it is Rk versus probability of this itself. Okay, Rk and image. Okay, and next what you have done is you have converted from R, applying what? A transformation function. So this is not the histogram. Okay, this is not the histogram. You are converting value of intensity from Rk into Sk. Sk is nothing but the output image. Next what you need to do, we need to find the histogram of the output image, right? So taking this as Sk, you're taking this as Sk, so probability of Sk. Okay, probability of Sk. Clear with that? Hello?
Yes, sir.
Okay, so already you know the formula for probability of Rk. Just what was the probability of Rk? Nk divided by m cross n. If it was Sk, means what should be the formula for Sk? What would it be for Rk? Sk means what it should be?
SK divided by
Sk
M
divided
cross
by
N.
divided by sk divided by m cross n. Okay, so it will be, so you need to find probability of sk, ps of sk, sk divided by m cross n. First thing we need to find it for which one? S1. So probability for S1 is how much? What is sk? What is the value of sk?
0.19.
Sk, that is the reduced value. Sk means how much? 790. Okay, sk S1 you need to calculate for what? S1, S5 and S7. So first you have taken what? S1. S1 is containing how many pixels? 790 pixels. So we'll be taking this as 790 divided by what is m cross 4096. So that would be 0.19. Okay, so that would be 0.19. So if you plot over here 0 to 0 1 2 4 5 6 and 7 0. Okay, you start from how much? S1. Okay, so here you take it as 0.05, next 0.10, 0.15, next 0.20. So it would be 0.0. 0.25. Okay, for 0, there is no 0. Next for 0, for 1 it is how much? 0.19. So this is for which one? For 1. For 1 it is 0.19. Next for 3 you need to
0.25.
2 fine. So probability of S2. So how do you get, sorry, probability of S1? So this is probability of S3. Okay, probability of S3 is how much? 1023. So it is 1023 and you 6 4096. So what is the value? 0.4. I'm getting it as 0.24. So for there is no 2. Okay, you just observe here, 1 is present, 2 is not present. At 3 it 0.24. For which one? For 3. For 0. Next probability for which one? 5. What is the value for that? 850 divided by 40.
0.21.
0.21. for fifth element 0.21, it is 0.21. Next, so there is sixth element, you need to take probability of S6, which is equal to, so how many pixels are there? 985 divided by 4096. ಎಷ್ಟು ಬರುತ್ತೆ? What is the value? 985 by 4096. How much? ಎಷ್ಟು?
0.24. 0.24.
Okay, so this is 0.24. So this is 0. Next is 7. So that would be probability of S7. So it is the pixels divided by 40. What is the value?
0.11.
0.10.
0.11.
So 7 is 0.10. So this is the equalized histogram image. Okay, you just observe what was the image. So the original is image. Okay, so every intensity was present, so the image was not brighter. Okay, so what we have done is we have spread the histogram. By spreading it, we have made the image as brighter. Okay, so this is your output histogram which is been equalized. So what they will be given is, it will be given as a 3-bit image and size is 64 cross 64. So here, since 3-bit, the value equals what? L equals 2 to the power of k. Okay, k is 3, 2 to the power of 3, so there will be L is equal to 8. Okay, there will be 8 levels. 0, 2, 3, 4, 5, 6 and 7 is the level. Okay, so the input intensity will be designated by R, so I written it as R and R7. Okay, next you will be taking the number of pixels with that particular intensity. So there will be 790 pixels with intensity 0. Similarly 1. Similarly, although n value is given here. Okay, when you add up all this will be equal to the pixels which is present in the image, which is nothing but m cross n. So m cross n means 64 cross 64, it would be 4096 element. So when you add up, it will be 4096. Okay, next what we need to do is we need to normalize this image. Okay, that is normalize the values, because histogram is nothing but it is a plot of RK. Remember always that histogram means at the x-axis, if it is R, probability of this value itself. Okay, so since we require a probability value here, we are taking the normalized value. PR of RK is nothing but the whole sum of the values. Okay, so here it is 790, means 790 divided by 4096. Next is what? 1023 divided by 4096, so that is 0.25. So you go on doing this for all the values, will be getting this PR of RK. Okay, Once you get this, you plot for RK versus PR of RK. Okay, so this is your RK and this is your PR of RK. Okay, when you do this, you'll be getting this as the original image. Now what we need to do, we need to transfer this into histogram equalized image. Okay, in order to do that, we'll be applying the transformation. When you apply the transformation function, so how do you get that S? By applying this formula, L minus 1 into J is equal to 0 to K of P R of R J. Okay, when you apply this formula, you will as S1, S2, S3, S4, S5, S6 and S7. You will be drawing the graph corresponding to RK versus SK. So what is your RK? RK is the original image. SK is what? Transformed image intensity. So I will be transforming the RK intensity into SK intensity. When you do this, you will be getting these values. Okay, but what happens here is whatever the values which you get is a fractional value. It's not an integer. Okay, so you need, in order to convert this into integer, you will be rounding up the value. If it is greater than 5 means you round up this digit to the next digit, else you, okay, here S naught is what? 1.33. Since this is 3, it is rounded off to 1. Okay, 3.0 means you keep, 4.5 means 5, next 5.67 means 6. So again here 6.2, since it is 2, we are retaining it as 6. Okay, 6.65 means 7. Now if you carefully observe over here, R0 is mapped to 1, R1 is mapped to 3, R is mapped to 5 and R4 both are mapped to which level? 6. S5, S6 and S7, all these are mapped to 7. So at the output, so here this is one level, second level, third level, fourth level and fifth level. There are only 5 intensities. Okay, out of 8 intensities you have missed the remaining and 4 is being missed. Okay, so now we need to calculate for each. Okay, so R0 equals 0 was mapped to 1. So R0 was actually containing how many pixels? Over here R0 was containing how many pixels? 790 pixels. So I'll be taking this as 790 pixels. Next, R1 is mapped as containing 1023 pixels. So you're taking it as 1023. Next, R2 is mapped to S was containing 850 pixels. So I've taken here as 850 pixels. Next, R3 and S6. So R3 and R4. If you consider 329. So if you look over here, so R3 is 656. So this is 656 and R4 is 329. So R3 and R4, 656 plus 3 pixels. Next, R5, R6 and R7, that is 245, 122 and 81. So 245, 122 and 81. So all those one 21 and 81, so total is 448. So it will be intensity level 1, 3, 5, 6 and 7. So now we need to write the histogram image. So it is nothing but SK versus probability of SK. You know the formula for P So for sk it would be sk divided by mn. So you just take this for 0, okay, for 0 s0, okay, there is no 0. So at 1, okay, p of s1 equals how much? 790 by 4096, so that would be 0.19. So writing it as 0.19. Again intensity 2, there is no intensity 2 is missing, so leave it. Next 3, so for 3 there are 1023, we are taking it as divided by 4, that is 0.24, so that is 0.24. Next 4, again there is no 4, it is missing, leave it. Next 850, so 5 is 850 by 4096, that is 0.21. Next for 6 it is 985 by 6, it is 0.24. Next for 7 it is 448 divided by 409, that is 0.10. Okay, clear with this? Hello, hello.
Yes, sir.
Okay, so this is very important from the point of exam. Go through it again. I'll be doing problems on this. There are many problems regarding this. You just need to understand the concept. They'll be changing the value and the way they give the problem. Okay, just go through this once again. Okay, I'll be ending the, you just go through this what I have explained and grasp the concept. Okay, that is the main thing which you need to understand. Once you understand the concept, you can problems. Okay, so I'll be ending the session here. Thank you.